right as I started the stream. Just turned off. Oh well. I thought I was gonna be able to use these RF wireless headphones, but no. Go Component Lab today. Gosh, what are we doing? That's right. So I feel a little bit better than I did this morning. So, as a reminder, if you go to my Twitch channel and go to events, you can actually see my schedule. If you go to any one of these, you can go to the series and you can get reminded when the next Go Component Lab is, which is usually this time, Tuesdays and Thursdays. I've been doing some unscheduled things earlier in the morning. Otherwise, I do a lot of game development. So we've been working on our RPC system, calling it qRPC, and we've also been working on, it's built on a multiplexing protocol. We've been using Quick. Actually, it works on Quick SSH, a couple of others, but we actually made a multiplexing protocol called qMux that was extracted from SSH, and we have an implementation of it in Go that works, and recently I was porting that to TypeScript for JavaScript. And that's kind of a parallel thing going on, just so we can start using it in JavaScript. But until then, we can continue using it in Go. And before we even started on this qRPC thing, you might remember we were working on the supervisor that's made for running, I don't know, running sub-processes for a main process and watching them. So if they change, then they'll restart them. So basically, if you have kind of a modular plugin system where the plugins are processes, and then we built something that actually used that, and we were calling it RPC daemon. I renamed it to qBus because we're going to basically, and it was based on my old RPC system called Duplex, just to use as we prototype, and now we want to replace it with qRPC, which actually will be very easy. Because qRPC is based on streams, we basically just set up some proxying. We don't have to really get too much into the protocol, so that's pretty cool. We're going to do that today. Probably won't take that long. And so we're going to kind of first work on that proxy, maybe separately as a sub-package of qRPC, and then bring it into our RPC daemon or qBus project, and then see if we can get it working, at least with the Go stuff, since we don't have a JavaScript implementation yet. So that's what we're gonna do. Although I'm tempted to, because we were so close on this, is to implement this method and see how far we can get on this TypeScript thing that we were working on earlier. Even though this stream is not called TypeScript, porting to TypeScript, I can't imagine it's that big of a deal. We might have time to do other stuff. So how about we do the bus thing, the hub, and then we'll come back to this if there's time. So I guess also if you're watching this on YouTube after the fact, I definitely recommend watching it 1.5 or 2x speed, since this is a 2-hour stream and there's a lot of like thinking and debugging and stuff in between. If you're watching live, definitely feel free to participate. If you're watching on YouTube and you want to participate, you have to go to Twitch to chat. But chat's here. I can answer any questions. And let me know what you think of this stream. And follow and subscribe and all that nonsense. All right. So let's kind of look at what we did. Hey, welcome back. It's good to see people coming back for this stream. It's a good sign. So we might remember this, where we built a kind of a custom server. We actually re-implemented how duplex messages were handled, so that we could handle our own register and then it was almost like a NAT, if you remember, where kind of like messages come in and they have an ID, and so we write that down, then we change the ID and send it off to the back end, and when we get it back, we change the ID back and send it back. It's kind of a mess. We won't really have to do that this time, I'm pretty sure. But it's interesting that we kind of, since I knew I was going to rewrite it all, I didn't really do a nice abstraction or anything. But this time we'll have kind of a nicer abstraction. I was calling it a hub then, but I feel like calling it a bus is a little bit more appropriate, as it is almost more like the dbus daemon eventually will be used that way. So maybe we'll make a bus package on qRPC here. Let's see, so this is what we're dealing with. We want to handle a method. We also want to read the header of a request. So let's follow this actually. Most of it is API, that's shared code between the client and the server. And when we say serve, I guess this is where the interesting stuff happens. So we've got a decoder, we decode call. Trying to think if there is, because, okay, so the other thing is that complicated NAT-like thing where we're writing down IDs and stuff. We don't have to do that here because it's at a lower level of the protocol. So that's really great. This is ultimately be very simple to implement. But I'm trying to think. almost like we want to create an interface so we can pass it to a server, and instead of it serving up an API, it'll do let me see here. If we call I'm a little frustrated because in terms of design, we're running out of like a kind of names of abstractions, because we have a client, we have a server, both client and server take an API. And an API is this thing that we can put handlers on. But API itself is kind of like a handler. It's almost like, I mean, if we're going with more metaphors from NetHTTP, it's more like a mux. Which is maybe a little bit confusing because we have this qmux layer underneath. Let's see. Serve mux. Yeah, you'd think that would help. Well, I've started it. This is a diagram that is not quite finished, but you can kind of see. You got qRPC here. This is maybe the protocol or spec. We've got qmux down here. Here's that. We've got our sidecar supervisor, which is being used for qbus. QC is not written yet. All of these represent this system that's kind of like a dbus, but made for, it's like a distributed dbus, I don't know. And then this is going to be used for a lot of stuff, but the most immediate thing is this project called Deskbot, which is mostly based around Electron D. But I actually have to get Electron D working before the 18th because I'm giving a talk at a Go meetup, so. The idea of Electron D is actually just exposing the Electron internal APIs over this API system, so you can use it from any language that you have a qRPC implementation in. So I guess you could describe the goal of qRPC is to be able to model and expose arbitrary APIs. And this is all part of a larger project. Which, talking to some friends, and I've been doing open source for a while. I've been writing software for decades. I've made some notable things. I actually feel pretty confident that when we get to here, it will be the most useful software in the world. Humble beginnings, though. Humble beginnings. So, serve mux. We've already got this handler interface, which is for serving RPC. But then we have to oh, it's narcissism for you. Let's see, we call this a API server. I guess we could create an interface called API and then just hide this as a lowercase API. Let's do that for now so we don't introduce more names for things. And the minimum I'll call it serve API. Okay. Okay, I think the only thing... Crimson, let me check this out real quick. That looks great. That's the magic of Bootstrap. You can make stuff pretty quickly that looks pretty okay. You're even doing like a custom theme or something. It's good stuff. Doing this over HTTP or gRPC? Neither. I guess you missed out. qRPC is built on a generic interface. Its transport just needs to have a multiplexing session. So any multiplexing stream system. We implemented a bunch. We implemented Muxado, which is Alan Shreve's API that exposes the framing layer of HTTP2. We did SSH, which has a multiplexing layer in its protocol. We did Quick, which is the protocol of the future, a UDP reimplementation of TCP that has multiplexing built in. And then we have QMux, which is the protocol that we wrote based on a subset of SSH. That is sort of my fallback. It's supposed to be an easy protocol to implement in other languages. Relatively easy. Probably the easiest you can get with flow control. And that's for things like, oh, let's use this over any arbitrary stream connection, so standard IO or Websocket or TCP. So this could actually work over nearly any interface, which is helpful. Alright, so our server now, instead of a pointer to API, we take API. And this says serve API. Let's see, and then the client has something similar, serve API. Oh, that's all fine, okay. I think that's all we need to do. Man, I'm loving this API though, so far. And I guess we can run a quick demo to make sure that it works. All right. Okay, our client is still calling the old method. Here we go. Now what? What is our demo doing? Oh, we needed a... That's an interesting error case. So we didn't actually give it a destination. Let's do a check for that. So let's see. Parse, I guess, happens in our serve API. So yeah, it's not going to catch it here because destination is not. We can do this. We can have this return an error. Seems to make the most sense. No destination. No destination specified, so that's where I can say. And then what is our endpoint? Demo. Oh man, I was getting rid of a bunch of stuff, so I guess we can make a new test, a simple echo that returns a string. Alright, so this should be at demo echo. Oh, but we don't have... Oh, hello is our argument. Okay. This is making sure everything still works. And we even made it better. So now that we have this API, we can create a new type of API. And bus. Let's see. Yeah. So it'll have an API. And let's see, so things are gonna register and then session. Okay, so I think what we'd want is a map string to transport sessions. Oh, and we have to do qRPC. Okay. So there's a couple of things. So the one thing we need to implement is serve API, which looks like this. And we can kind of start by copying this one and then modify it to do what we want. Let's see. So we have to do something that we would do in local tunnel and grok, Allen Treves and grok. But because you're going to you basically want to hand off a connection and replay what you want to read a little bit of it so you know what to do with it, and then hand it off and copy it to some other connection. But you already read some of it, so you have to read that into a buffer and then play that first. And so it's probably like a bytes buffer, and then we can do a T IO T reader, and we want to, I forget which one comes first. Not being particularly helpful. Okay, so the reader and then the writer. Let's just, what's this? Oh, because we're gonna have to call it qRPC. Let's see what else needs that. Just in case later on, I want to make sure that they're. Oh, I'm not going to be able to do that. I'll have to make my own responder, maybe. I don't know. We'll see when we get there. Because we're not in the same package. Alright, so we get the call, we decode the call. Let's see, API. Basically, if it's part of the API that we have implemented, we want to hand it there. You know, this is interesting. What if we did this as middleware? So the idea here is that the API, you'd create the bus and then you'd have it create a server with a bus. But maybe, what if APIs had like a default handler? I don't think they have that concept in this Muxer. I think some other ones have. You would just do slash, and anything that doesn't match, I think, would just match with slash. You should probably do the same thing. In which case the bus is not... Well, no, because we're talking about the handlers, not the serve API. Got 2 layers of handlers. I'll keep going on this route. So we do want to parse it. But at that point, we want to check to see whether it's in our API or not. Doesn't have any other fancy methods, does it? We might want to have something where it will tell us if it handles a particular path. Handler. I guess we could do a like handler, and then that does a lookup. And it returns a handler. And it would basically do this. Doesn't exist. And the break. So then we could replace this. And then make this part of the API for API. I don't know. Something kind of fishy about it. We'll see. It might be that it's that we have handler, but we don't have the things that register handlers. I don't know. Or that the handler is kind of dealing with the handler abstraction, but serve API is this lower level thing. Something about it's interesting. But anyway, so now we can do this. We do get a handler. P API handler. And then if handler isn't nil, then we'll just serve it. Otherwise, this is where we do the interesting stuff. Oh. Yeah, I guess we would want to do that. Create a responder. If other things are going to need to make a responder, I guess we could do a new responder. Alright, we just can't call parse. That's right. I don't see why that needs to be private. I guess we're not doing some other stuff that we need to do. We would need to do this as well. Which, again, we can't do because it's private. Starting to push on my sensibilities. I'll have to come back to that. This is a qRPC client, and this is no, that's just the name. So this will work effectively like a regular API, wrapping that API, but let's see. thing is I want to do an API and then do handle func. Oh God. I have to start worrying about, we don't have to worry about path stuff yet. We'll just do it. Register func r qRPC responder qRPC call. Let's see, we want to do a bus too. I see. Okay, so the thing is, let's see, if I register, do I have a reference to the underlying transport stuff? Because I would need that here. That's true. All right. God damn it. All right, I don't like how this is right now, but I'm gonna do it just so we can go forward. Which means my bus needs to implement it too, but I guess I could just embed it. If I were to do this, then those should all be exposed. And this is still correct. Yeah, everything's good. Let's see, sessions. Caller. I guess we do have a reference to it because we could say caller. Except type assert it into a client and grab the session, maybe? I guess that's fine. See, I simplified this one. I put it in here. This is a good example. Okay. So it's paths, I guess we'll call them. I see, I just did that. Okay, that's fine. I will do that. Let's lock this bus up. Bus sessions. Session. And I guess we can return like a positive, I don't know. I guess no. Alright, so in theory now we have an API that serves register. Maybe we call this backends. I guess we're gonna set this up too. And then we can basically do the same thing here, handler. But we'll actually just do it for the prefix. In fact, I wonder if we should just do that here as well. Has the same effect. I mean, if it was HTTP, we'd want to make sure that there was a slash at the end before, but yeah, for now, let's just do this. All right. Looking at our back ends. This is call destination. Which is what, a transport session. I guess we can make the responder sooner. And then the interesting part is what happens when we do have the back end, because that's when we need to replay this buffer and then hand it over. So now that we have a backend, backend channel, got this buffer, we're gonna write it out to the channel. So we're replaying what we read so far. For now, we're just doing all this. And then, once we've written what we've read, actually, you probably want to... Do you think this decoder needs to be closed? Do you close decoders? No. We just don't want to read from it anymore, so we're going to do a two-way copy, basically a proxy now. So I'll just copy until they're done. Serve API. And I don't remember if this is called in a Go routine or Go serve API. Okay, so we're fine to just block until it's done. Let's make an example for this. So, call bus. This is package main. Okay, so like this example, start the bus. Bus, new bus. All right. Make and connect a backend. So it works kind of like a client. And then we serve an API. So let's make an API first. This is actually, why don't we use our little convenience thing. qRPC, export func, and create a function that takes an argument, which we don't need an argument. I guess we never tested it without an argument. I'll take an argument and then what? Oh yeah, we did that all. Bullshit. I'd love to fix this. So we don't have to do that. And then this is gonna dial the bus address. Let's see, client API equals API. What? And we go and run that, serve this API. But we also have to call something to register it. So client call register. Something called hello. We don't care about the response. So this backend is now connected and registered, and so in theory, if we get a new to make and connect a front end. Which is much simpler. We don't need an API on it. We don't need to serve anything. Var response string. Doing an empty string just because we didn't test nothing. Shit. Yeah, we do need to call these something else. Backend. Backend connection. Oh. Backend session. And then here we'll call it front end session. So if it works, we should get hello world. Nope. Plus 42. C, caller, client. Decode should work. Oh, bus footage. What do we have here? This. Our call to panic failed. didn't like nil. So that's something we need to fix up here. We should accept nil when we do calls, reply. We want it either way. If reply is nil. No, if it's not nil. Otherwise, don't decode into it. Okay. I want to know where we're at when this happens. So we have a race condition? Jesus. How come we're not getting this at all? And we register, this has to finish before this happens, so listen TCP. Let's see. Guessing this is on. Let's pick it apart in here. Because this is actually, should be getting this far. Should be able to say. That shouldn't be called anymore. So this buffer, we're going to write to the channel because we just connect to it. We might want to do this after the streams are set up, because that actually initiates it, and we want to have these set up before. That's probably the race condition. I don't know why I didn't see that before. Well, it doesn't seem to fix this particular race condition. This is gonna read. Okay, but that shouldn't affect the decoder. Yeah, actually we don't want this to happen first because we want to make sure this is written first. So it actually looks more like this. Make sure we get the response stream set up. Write the initial thing, and then continue reading the channel. Okay, that didn't help either. This is odd. This should just kind of work, but so this is a matter of our back end here, not decoding. See, it's decoders. Let's check decoder. Maybe it is. see, any suggestions? We could look at the standard out. Decode. Well, I can at least compare the bytes. Let's try and look at those by teeing this as well. And we'll, if there's an error, we'll print out the buffer. That's a strange shape for the buffer. I mean, but I guess what I was gonna do is do the same thing here. What are these brackets? I mean, am I just doing something stupid like this is the back end? I think I am. No, this is, I'm reading and I'm writing back. Is write 2 behaving differently than I expect? Rise the data to W until the buffer is drained. So if I see, this whole point here is this decode is going to cause a read on this, which is going to write to this, so I should have that in there, and we see that it has that data. But what's weird is oh wait, what? No, I want to no. We write to the back end. All right, now everything works perfectly like it was supposed to. Of course it does. I don't need to do this anymore. There it is. Our demo, we were gonna make sure we didn't need to send an argument, so let's try that. It does not like that. Ooh. I don't think it has to do with what I just changed. What did I do now? I didn't add. That's all. That's all. No wonder it race conditions. Seems to be fine taking nil input, which makes sense. I guess I'm more concerned about this being able to take no inputs. Yeah. So that's our export func we need to support. This won't do anything. Has a param. This is fine. This is going to be an empty value. But we do want to send the receiver. It should be fine, I think. We do want to do this though, because we're going to get nil either way. But whether we want to pass it in is the question, so this should fix it. Nope. Oh. Yeah, I know. What's the, I guess param type? Type of empty interface? That could work. What? You don't like my empty interface? I mean, that's... Wait, it's still hitting this? Has param. should be num in. And receiver's nil, so num in is greater than 1. And we return, otherwise has param. Greater than 0, right? And yet for some reason this is running. Oh, wait, 293. Oh. I mean, this isn't... That's not nil. Maybe you can only do kind on something that's not nil? Param value. I guess we don't need to decode it. We could skip this whole thing. Okay, so now it works with no params. Good. We made our export thing a little better. Well, we finished our bus. I guess we can start hooking it up over here. Start renaming. Wow, we're not going to need any of this stuff. We won't use Websocket yet, although if we have time, we should do that experiment. All right, where's our main? We don't need any of this. It's our register. This is all our mapping. So basically we would copy this, start the bus. Don't need this even. mean, yeah, I guess we can TCP for now, that's fine. We do that, then we set up the supervisor. That's pretty much it. Oh, you need help? Sorry, my chat on the other screen is faster than this one for some reason. What's up? All right, let's turn these off. Demo.js, demo Python. Oh, you'll have to be more specific, though. Give me examples. Oh, yeah. Well, it's a good question. But you need it to be is this a shared database? Or is it something that just you use? Yeah. Okay. So, if you did anything that meant you were going to use it from any other browser, basically, if you're always using it on the same phone, the database can live in the context of the web page of the browser. It means if anybody else goes to that page, they'll have their own copy of the page because it's specific to your browser if you did local storage. I don't know if you want to use local storage, but it's definitely a good first step. If you want correct. So this is uncommon that this would be a good solution. So the next thing up is you need to have a persistent database somewhere. And you need to store stuff in it. There's a bunch of APIs that do this for you, and maybe the easiest one, I don't know if it's easy because now it's all Google stuff, but one of the most, I don't know, conventional. So this is a service that'll store stuff for you. It does a bunch of stuff, but read and write. So you'd have a representation on the page, and you need to load that representation by generated elements or whatever, using jQuery or whatever, based on every object in the database. So you do something like this, and then you would have to store it in the database. There could be something that makes this even easier, but it really depends on like what level of abstraction you're willing to deal with. But I recommend Firebase. And there might be some like sync with. I don't know if you want to use local storage, because local storage doesn't actually, it just saves a bunch of strings, which is really obnoxious. But maybe there's something like this. Anyway, I'm sure you can look into it, but you need to have some kind of database that exists somewhere in a shared reachable place. And so the easiest thing to do is use a database as a service. You can look for others. Database as a service. If you're comfortable, but you want something that you can use from the browser. And so that's why I'm thinking Firebase, because it's one of the best ones. This might be, this looks new. Also looks kind of, this is one you could look into. Whatever seems easiest for you to implement, really. App base. And yeah, if you're using Twilio, Twilio has a what do they call it? I say Twilio because you mentioned sending SMS messages, which you'd use Twilio to do that. Twilio Sync. Show me the API. Oh, it's still in early access though. Yeah, this is a little bit easier than Firebase. And Twilio documentation is, you know, great. So if you feel like you want to use this and they don't have a public, I can get you access. All right, cool. If you want access, make a Twilio account and then email me, program@gmail.com. We could set it up, and then if they don't get back soon enough, you can just start using Firebase. I like that you're making progress, though. That's great. Let's see, so we can replace this with our, basically just this. Actually, demo go. All this garbage. Right, we need to have it register. What did I say? I guess I deleted it already. We don't do a server. Okay, client to server. This is more like our back end. We're serving echo. All right, so we could actually maybe do this. Yep, this is a nice little back end. I don't know what this is. So now if we go back out here, we should actually be able to run this, and if that's the case, we can hook up a client to talk to it. There we go. I must have had a client that I deleted. Well, we were going to start a client anyway, so we can create a new. Oops. Okay, so let's see, we were making, let's see, this demo. How'd it work? Okay, yeah, so we're setting this up. And really just this. That. It's an echo service, so we could do this. We just call echo. I think this is all we need. So there we go. If we were to make a different, so I guess to explain what's going on, we've got our bus daemon, which really doesn't do anything but, you know, let things connect to it and route to other stuff. But we can connect to it like it's an RPC server. These other things are connecting to it like an RPC server, but then providing functions. And they register them. This API would change, but they register them, giving the name, and if anything calls the bus with that method, then it gets routed to this one. So that's what we had working originally using duplex, but now that we rewrote our RPC, it's significantly simpler. And I'll kind of go over that again in the recap that I'm going to do probably in the next 5 or 10 minutes. Oh yeah, I was going to do an experiment with Websocket real quick. QMux session. I can mostly reuse this. All right, let's make a new transport. WebSocket. I deleted the stuff that we were doing with WebSocket, but let's go to our prototypes. So this is where I'm going to be pushing stuff, where you can go to follow along, get access to this code. But our old example did have our Gorilla adapter. I'll leave that for this transport. And what else? Kind of all there is. WebSocket server. I guess I do have to make a WebSocket server. That's just this function. Oh, but I would need to do this upgrade shit. And then we want some of these. We'll call it WebSocket. Let's see, address. You don't need any of this config nonsense. Yeah, it's a little different. Listen TCP gives us a listener. Okay. Yeah, so we will do the same. But then we have to make a WebSocket server. No, we don't do this. Also, definitely not that we want to do. I guess make a mux. I'll have to look at it in a second. I'm almost done. But with this, I can do what? Right? Okay, let me think about this though. How does this API work? Oh. Our listener is... We had to make a fake listener. That's fine. We're not actually returning the listener for this. We're returning a listener that will... handler func. I know there's one in here, handler func. Right, HTTP handler func. It actually looks super weird doing this, but whatever. Just listen and serve. Actually, yeah, just listen and serve. And we'll basically just have to make a channel that we can communicate between our fake listener and our HTTP server. Accept and close. Well, actually, I could actually have it ramp our listener. So if you called close, it would close the thing. Sure. So how do we get the listener then from... Take a listener. Okay, so it is like we were gonna do with TCP. Create a listener here. Do this. Tell it to serve on this listener. And then this is a Websocket listener. So this upgrades it, and then we're going to basically this new session. Oh, yeah. Actually, why don't we... Right, QMX session. Where are we gonna wrap it? Ramp it up here. I guess something that implements a connection interface. I don't think it does, though. It doesn't. WebSocket connection. fuck it, it could just be a IO read write closer. Websocket. Does this have to stay around? Because it does. I guess I should do the session up here then. All right, I had it right the first time. God damn it. What does this need to take though? A net connection? I mean, it's not really, but we can try and make it like one. And then session wait. L. This is our listener, and this is our session channel. Oops. What? Close method has a pointer receiver, and close doesn't. That seems ridiculous. Read method has a pointer receiver again. Yeah, so now the other connection stuff. I will, what's this problem? Oh. Yeah, no. Cannot use session. Oh, its accept is wrong. Fine, make it a QMux session, Jesus. Wait. QMux new session. Oh, right. This is the underlying session. Okay. Yeah, I think this is fine. Return Websocket listener. Oh man, we're past 7. I don't know, I want to keep going. I had a slow start today. And I'll look at this. I'll look at your, let me see. Oh, I see. Yeah, well, it's hard to tell visually what how your logic is working, but probably. Is it a theme? Oh, this, data tables? Oh, yeah. But data tables... Actually, data tables, is that new? Data tables. Oh, is this just it? This is what we were just looking at, right? Okay, cool. Yeah, you could use data tables and based on jQuery. Yeah, that'd be perfect. Perfect for you, actually. And then they should basically give you all the code here on how to populate it and fill it out. Totally use it. Okay, so now the last thing, I think we can take care of this really quick too. But did we have I guess the client was in our module for this. Default dialer, blah, 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 blah. That's all it is right there. I mean, in theory, actually, we don't have to do this if we just return this error. Okay, so now the only thing left is to make sure we implement the rest of those net connection interfaces, which is whatever. And now I can take it as a net connection. So now let's go back to our demo. Run that real quick. Run demo. Right. What is it? Echo? Demo? Demo echo? There we go. So we should be able to replace this one now with a WebSocket. Oops. Okay. Didn't work. Double check this real quick. So read and write are sending messages as text data. We actually want to send binary data now. We could actually WS connection right. Oh, they don't even have a regular write. Oh shit. Data messages. Package use the text message binary. Read message. Read message. Message type. So I guess that doesn't matter. But I will make it a binary message. And what is the right message does not return anything. Okay, maybe it just needs to be sent as binary. Nope, that was not it. Because we're not using these, so I can't imagine that that's the problem. I feel like more it's like this pointer nonsense. Like, I think these need to be pointers. What does the interface have to do with whether there's pointers or not? That's stupid. If it implements the methods, it implements the methods. Something else is the problem here. Because it needs to be an instance. That's all. That was the problem right there. All right, now it should work. Yeah. What language is that? Oh, and it's still not enough. Not enough. Yeah, I thought maybe. We're very close. Something is, I don't know if it's just like, yeah, so then it's just gonna sit there. This has done its job. We have this. Which, I already know this works. Give a shout out for my Uncle Benjamin. Shout out to Uncle Benjamin. That's what you wanted. I hope you're not a bot. So, I mean, this is working pretty much the same as QMux, but over WebSocket, and I can't quite tell. Can't quite tell if it's QMux or if it's like my WebSocket adapter or what, because it's probably not any of this. We're returning everything. Everything works as usual. Let's see, session net connection. We're doing writes. We're not getting any errors either. It's interesting. I'm pretty sure I'm error handling enough. Like, we should panic if things don't work out. All right, well, let's see how far we get here. I'm pretty sure we will. It makes the call. And it's just waiting for something back. So. And this is doing read, write, blah, 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 blah. And we're wrapping this up in a QMux session. reusing this. Which doesn't do anything but wrap up QMux session. QMux channel. Once we have dial WebSocket error, we're not getting an error here, and we're not we're panicking on an error. So this is it's connecting, right? And we have a turns a session. And we know actually that this all works too, because we saw that we got this far and we were even able to return this. So I guess this is just a matter of taking QMux over WebSocket and it not really working. It seems so strange. I guess it's been a little while since I've used this. I wonder if there's something else I'm not thinking about. Is it an origin thing? I don't think so. It's on TCP because it's a web server. We serve the web server, we upgrade to WebSocket on it. If our codec was JSON, we could watch the frames go by, but I mean, we could just call this a failed experiment for this stream. Kind of need to get this to work though for later. Let's revisit their docs and make sure. Read message, write message. I'm right closer, write the message. read until the snippet shows how to echo messages. Connections support one concurrent reader and one concurrent writer. Applications are responsible for ensuring that no more than one coroutine calls write methods. I think Qmux does this, so. Upgrade would fail. Be clear. There would have been an error. Well, we can do this and see where it was waiting. .285 is waiting at in open. Waiting for the message to come back. Open, huh? Websocket 81. Do I need to buffer this? Yeah, I didn't think so. things are always going to be sitting on accept. So we got open and what? Transport, we got that listener. Chain receive, we're waiting on that. This is the first time I've used wait. I don't know that it works. But it is sitting there waiting, so I guess that makes sense. It's waiting on read. Waiting on accept. What do you got, Crimson? Yeah. Okay. Sure. I guess you want to refollow the instructions. Seems like some JavaScript is not being run. I guess I could go over this and see if there's something that wouldn't make sense for WebSockets. Read a size. It does need to read. Right, not full messages. This was designed to write full messages. We want one of these writers. Let's look at the code for their write message. I never understood in terms of writer for the next message to send. So you're saying if you don't write it all, okay. What I want is I need to know how to control messages. Let's read the connection process to close. If the application is not otherwise interested in messages from the peer, the application should start a routine to read and discard messages. I don't know why they don't have something that just like aggregates and gives you like a read writer thing that knows how to one reader on a connection. Next reader discards the previous message if the application has not already consumed it. Alright, we'll do this where we actually create a buffer and read into it and blah, 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 blah. And if we do that, I don't think write will matter that it's writing a message per thing. It's mostly read. this just becomes... What does this loop look like? Next writer. I mean, that should be it. Oh. Doesn't it though? Oh man, come on. Except now we also have to do this other Go routine to read. This should work. Almost. What? Who's concurrently writing? Fine. It's closer. I don't see anything wrong here because the message frame size doesn't matter if both ends are just reading messages into a buffer. So the data of the message in the buffer, as long as that's in order. And there's only one thing reading. Reads from a reader, gets a reader, copies it all in before getting the next one, so. I'm just wondering if there's something maybe at at boundaries, but like if there is an empty message, there'd be no bytes. I guess we also can control well, obviously if we could just see stuff printed out, but use a paste bin. You can show me your code with like a gist or something like that. Use what one? This is buffer size nonsense. Parameter specify the size of buffers to use. Well, tell me though. What? Okay. If a buffer size is 0, then buffers allocated by HTTP server are used. The I/O buffer sizes do not limit the size of messages that can be sent or received. So then what is the point? It's creating a buffer. And this has to be after these. Well, maybe not. Yeah, it does. So move this after your includes. Like the buffer sizes. If I set the buffer size to like 1, I don't know, we'll see if that makes a difference. Well, it should. You don't have, you need to give something the ID of example. Oh no, it does have that. Right, because it wouldn't be it. Okay. I don't know. Are you getting, can you log in here and make sure that this is being called? Is this consistent now with tiny buffers? No, it was always like this. Well, concurrent write to a WebSocket connection, that doesn't make sense because we are literally locking it down here. Except for this, I guess. Now we're literally locking it down. Okay, that was the problem. Okay, it's being racy. And this is clearly WebSocket's fault since we've done this so many times on other normal protocols. Demo 91, that's... What is that again? Call. Call gives us a panic. Close sent. I mean, what happens when you call close on the thing, right? Close handler. What do you think the close handler would do? I wonder if they designed it so that they're like, oh, it could recover from a WebSocket. Like you'd upgrade and then downgrade back to something. I don't know. That'd be silly. It's called. Wait. The handler function. It's okay. Yeah. Was read the connection to process. Wait, what? It's called from. Oh, I see. The connection read methods. I kind of want a full example of this thing because they're making it really difficult to actually use it. But I think it's more the protocol itself. They just gave you kind of a low level thing. I'm sure there's no, that's dumb. It doesn't do anything interesting. All right, this one looks more real. Read all. Let's read or write close. As a validator, okay. If it's not text message, do we still copy R to writer? See, what the fuck is this? Why would we need to do this? Do we really need to? I mean, we don't really need to ping pong. It only needs to, what the fuck is this? Whatever. I see, because it's writing a ping pong thing. Okay, this is just updating the deadline with the ping. Cool, cool. I don't see anything else, though. Interesting going on there. I mean, the fact that this demo works with every other protocol means that there's something, we're working with WebSocket wrong. I guess it's an hour late too. I guess I'll do a wrap up. This kind of stuff. I'll probably come back to it and figure it out. So let me think about what we did today. Okay, recap time. Okay, so today we built I guess it's not here. Today we built a bus or a hub for qRPC. We implemented it as something that implements the API interface so that we can pass it to a client or a server. It itself has an API that has a register handler that then takes the underlying session and puts it in a map for backends. Register takes a list of methods for now and basically creates an entry in backends for each of those. So then when it gets serve API, it will read the channel in order to decode the call, so that we can parse it ourselves if it's register or anything else in our API. But we actually we tee that into a buffer so that if it's not something that we can handle, we hand it off to a backend. If the backend exists, then we open up a channel and we basically start setting up a proxy linking those two channels, the front end channel and the back end channel, but first writing what we had in our buffer. So we're basically replaying what we've read so far, and then after that it's just joining those connections. And so that was way simpler than our original implementation of something that does this using duplex, the old RPC protocol. We had to do something that, parsed all the messages that came through differently, so we had to re-implement duplex code, and it's kind of a big mess. And since we basically wrap this up into a nice API, our new version of this is incredibly simple. That's it. Because we set up a server and we set up a bus on it, and that's it. Everything else is the same. So we basically just got rid of all the code and replaced it with this. Since we don't have protocols that work for Python or JavaScript yet, we only updated our Go demo module, which before, also with duplex, you can see, it has to do all this stuff. And now it's as simple as defining an API, connecting to it, calling serve API. We made a quick little client that hard codes passing hello, but displays the response. And so we were able to talk to our bus, and it serves it up from our demo process, and yada, yada, yada. So that worked. Then I tried to go and implement a new transport for qRPC, since previously we used Websocket with duplex. So I wanted to create a Websocket transport here, and the idea is that we would run qmux on top of this WebSocket transport. The problem is, you know, a WebSocket connection is not, at least with this library, does not like being treated like a read-write stream. And so we have to kind of create our own reader loop and then copy that into a buffer and have our read off that buffer. Problem is, this isn't good enough and it's just not working, and everything else here we know works. Is just implementing some of the glue code from before and setting up a standard server. Then what we're trying to do is take our WebSocket and convert it into something that looks like a net connection, and then we reuse all our qmux code that would work with that works with like TCP. So the problem is translating over WebSocket for some reason doesn't work. This is the first time I've ever run into this problem with WebSocket, which is really odd. But I think it's because I'm not working with normal frames, and I'm, you know, qmux does do a lot of you know, reads off the line within a message, and so it kind of expects that all to be kind of an ordered thing, and that's what led to doing this buffer, because apparently if you do a read, yeah, that's the thing is, so before usually I would create this interface. I actually just want it to read and write a message when you do read and write, as opposed to a stream. The problem is if you read a little bit, if you don't read the whole message, then you read the first part of the message and then throw the rest of the message away the way it worked before. So that's why we have to read all the messages into a buffer, and then we read off that buffer. But we're still having problems, and it's definitely specific to how we work with WebSocket, because every other transport works fine. So it's just some little trick. Again, today's been a bad day with running into these blockers that are frustrating. This isn't as bad as earlier, but anyway, that's it. We've got a new implementation of QBus. We just need to get a WebSocket implementation, and then in parallel we're working on our JavaScript implementation of qmux, kind of coming at it from the other angle. And then once we have those things, then we can recreate this JavaScript demo. Python will take a little bit longer, but we can kind of put that off for now. My goal is to be able to talk to the JavaScript API. So I guess in parallel we're also working on that object manager, so we'll come back to that next week as well. Anyway, that's it. Thanks everybody for hanging out. Crimson, good luck. If you want to join my Discord server linked on the channel page, you know, I can try and help you out there. Otherwise, you can try and catch me next time. My events are all scheduled a week ahead, so thanks everybody. See you next week, maybe tomorrow.